Radius of gyration of a body. Radius of gyration of a body. In diagram, a rigid body of mass m rotates about the axis of rotation AB. M1 is the mass of the first constituent particle which is at a perpendicular distance. M1 is at a perpendicular distance R1 from the axis of rotation AB. R1 is the perpendicular distance of the constituent particle of mass M1. The rigid body rotates about the axis AB with an angular velocity omega. Second constituent particle has the mass M2 which is at a distance R2. An nth constituent particle having mass Mn will be at a perpendicular distance Rn. This is a constituent particle of mass Mn which is at a distance Rn from the axis of rotation AB. So this is the rigid body of mass M which rotates about the axis of rotation AB with an angular velocity omega, and I is the moment of inertia of the rigid body about the axis of rotation AB. We can consider a point K, we can consider a point P which is at a perpendicular distance K from the axis of rotation AB. Here K is the perpendicular distance of the point P from the axis of rotation AB. Now the entire mass, that is whole mass of the rigid body, is to be concentrated at the point P. AB is the axis of rotation, and the total mass of the rigid body, that is capital M, is concentrated at the point P which is at a perpendicular distance K, and the concentrated mass at the point P. And here the total mass of the rigid body M is M1 plus M2 plus dot 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 plus Mn. That is the total mass of the rigid body which is concentrated at the point P. The total mass capital M is concentrated at the point P, and the point P is at a perpendicular distance K from the axis of rotation AB. And here in the second diagram, capital M is the concentrated mass at the point P at a perpendicular distance K, and in this case this concentrated mass will rotate about the axis of rotation, and it will have a moment of inertia I prime. If I prime equal I, comma, K is the radius of gyration, the perpendicular distance K is the radius of gyration of the rigid body about the axis of rotation AB. So K is the radius of gyration. When a rigid body of mass capital M rotates about the axis of rotation AB, rotates about an axis of rotation AB with an angular velocity omega, comma, the moment of inertia of the rigid body, about the axis of rotation AB, will be I equal sum of moments of inertia of its constituent particles. That means I equal M1 R1 square plus M2 R2 square plus dot 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 plus Mn Rn square. So this is equation 1. I equal M1 R1 square plus M2 R2 square plus dot 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 plus Mn Rn square, where M1 comma M2 comma dot 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 comma Mn are the masses of the constituent particles of the rigid body, n number of constituent particles which are at the perpendicular distances which are at the perpendicular distances r1 comma r2 comma dot 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 comma rn from the axis of rotation respectively, r1 comma r2 comma dot 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 comma rn respectively from the axis of rotation AB. If the total mass capital M if the total mass capital M of the rigid body were concentrated, not was, in this case it should be were concentrated at the point P at a perpendicular distance k, at a perpendicular distance k, at a perpendicular distance k from the axis of rotation AB, from the axis of rotation AB, then the moment of inertia, of the concentrated mass capital M at the point P, will be concentrated mass at the point P would be I prime equal mk square, mass into square of perpendicular distance is the moment of inertia. That's why I prime equal mk square, which is equation 2. Now in the diagram, capital M, that means total mass of the rigid body, is concentrated at the point P at a perpendicular distance k, and I prime is a final moment of inertia of this concentrated mass about the axis of rotation AB, which is mk square. If I prime equal I, comma, k is the radius of gyration, of the rigid body about the axis of rotation AB, Therefore, the definition of radius of gyration will be the radius of gyration of a body about an axis of rotation, about a given axis, that means axis of rotation, is the perpendicular distance of a point P from which, from the axis of rotation, is the perpendicular distance of a point P from the axis of rotation, comma, where if whole mass of the body were concentrated, the concentrated mass, if whole mass of the body were concentrated, the concentrated mass at that point P, shall have the same moment of inertia, as it has with the actual distribution of mass, Now I prime equal I, or mk square equal m1 r1 square plus m2 r2 square plus dot 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 plus mn rn square. Now we can draw the diagram again. This is the rigid body and AB is the axis of rotation, M is the total mass of the rigid body, and AB is the axis of rotation about which the rigid body rotates. We consider a point P which is at a perpendicular distance k, same axis of rotation AB, and at P total mass were concentrated and the point P is at perpendicular distance k. M is the mass which is concentrated at the point P. I prime is the final moment of inertia. In this case, I prime equal to I. I prime equal to I. Therefore, mk square equal, m is taken common, m bracket open r1 square plus r2 square plus dot 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 plus rn square, where we can assume that all the constituent particles will have the same mass, where all the constituent particles have the same mass, that is m1 equal m2 equal dot 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 equal mn equal m. We can assume that mass of each constituent particle is small m. Small m capital N k square equal m r1 square plus r2 square plus dot 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 plus rn square. Here it should be small n, small n, where n, small n is the number of constituent particles. Small n is the number of constituent particles. In the expression we have capital N, it should be small n, and capital M is the total mass of the rigid body, which is small n into small m. Therefore k equal r1 square plus r2 square plus dot 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 plus rn square whole divided by small n, not capital N. It should be small n because small n is the number of constituent particles. So in the previous line we have to make a correction, that should be small n. So finally we get k square, we get k square, then k equal r1 square plus r2 square plus dot 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 plus rn square whole divided by small n under square root. So k is the radius of gyration, which has expression root over r1 square plus r2 square plus r dot 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 plus rn square whole divided by small n. So this is the radius of gyration of this rigid body about the axis of rotation AB. Hence k has another definition, that means radius of gyration has another significance or definition if constituent particles have the same masses. Radius of gyration of a body about an axis of rotation, is equal to the root mean square of the perpendicular distances, root mean square of the distance of the constituent particles of the body from the axis of rotation or from the given axis rotation, provided all the constituent particles of the body have the same mass,